Hi, in this video we're going to take a look at an application of lambdas in sorting. So first of all, I want to point out that Python has a method for sorting called sorted. We can look at it. And it basically is a method that gets called a function that takes in an iterable. So you can supply a list, you can supply a dictionary, but because a dictionary is iterable, you can specify a set, you can specify a tuple, whatever thing you want that's iterable, a string even. And it will then return a list, so it's always going to return a list, and it's going to contain all the items from the iterable in ascending order, based on whatever the natural ordering is. So if you're dealing with numbers, it's going to use numerical ordering. If you're dealing with strings, it's going to do a lexicographical ordering. So it kind of depends on what you're looking at. If you have a custom type that you've built, you may want to, specify what ordering means and looks like for your particular class. So let's take a look at some examples. Let's start with a list that's going to contain some numbers. Let's say 1, 5, 4, 10, 9, 5. Well, we got 5 already. I don't want to do double, but let's do that. Okay? And we can sort this list. And remember, it's not going to do in-place sorting. This isn't sorting L. It's going to sort L but return a new thing. L will be unaffected. So here's the sorted list. L is still what it was originally. So I just want to point out that sorted is not an in-place sort. Okay, so that's how sorted works. But you'll notice that it has a keyword-only argument. Comes after that star over here. Has a keyword-only argument that defaults to none. Now what is that? Well, that's used to change the way in which items are ordered. And it does that essentially by applying a function. So this key has to be a function that will then get applied to each element in the iterable. And so each iterable element will have an associated value. That's the result of the function being evaluated. And the sort is going to happen based on that value there, not on the actual iterable item itself. So let's see an example. Let's see what I mean by that. So let's start with another list and let's put in some characters. So C and maybe a capital B, then we'll put a capital D, and then we'll put a lowercase a. Okay, so there's our string. Now we can sort that. We can say sorted L, and that returns this list, which is odd because capital B comes before A. That to us, that's not necessarily, doing a dictionary ordering because, well, B doesn't come before A, it should come after A. But remember, what's happening here is that capital B is a character and lowercase a is also a character, but they each have a character code. And we can see what the code is by looking at this. We can call this function called ORD, which is the ordinal. So we can look at the ordinal of A, or the character code of A, which is 97. If you look at an ASCII table, that's essentially what it is. A has a character code of 97 in the ASCII table. We can also look now at the character code of, let's say, capital A. Well, the character code of capital A is 65. So when you do lexicographical ordering, the capital letters actually precede the lowercase letters. And that's why this list is sorted this way, where the capital letters actually came first. They were ordered correctly. B came before D, and little a came before little c, right? Lowercase a came before lowercase c. So that's correct within the uppercase and lowercase. But of course, because lowercase and uppercase characters are not the same characters, they have different character codes, the ordering is going to be affected. So in this case, we might want to be able to do an ordering that is case insensitive. In other words, it's not going to care whether we're looking at a lowercase or uppercase b. So how would we do that? Well, we can do it again using that key. What we're going to do is that to every element in this list L, we're going to associate another element that we're going to use to sort by. And that element is going to be, I'm going to pick the uppercase version of each one. So basically we're going to sort each element based on its uppercase value. So how would we do that? Well, we'd say sorted. We again want to sort L, so sorted L, but the key now is going to be something that transforms each element to its uppercase equivalent. So we're going to do a lambda for that again. So lambda, it's going to take some element, let's call it S, and it's going to calculate and return S.upper. right? So now the associated value with each element in the list is going to be the uppercase version of that element. And so when we do that, now we get our case-insensitive sort right here. Okay, so that's another example of where we'd use a lambda. So I'm going to stick to the sorted method because that's, kind of a very typical way of using lambdas. So let's take a look at some more examples while we're at it to see how sorted works. Now we might look at a dictionary. So let's look at a dictionary. Let's say DEF is 300, ABC, the key ABC, oops, I guess I should try and keep my quotes consistent. ABC will be 200 and GHI will be 100, let's say. Okay, so now if we look at D, we have ABC 200, DEF 300, GHI 100. Again, we're not guaranteed of the order in which this is being displayed since this is an unordered kind of iterable. But we can iterate it. If you remember, what happens when we iterate a dictionary for E and D, print E, we are iterating the keys, right? So if we iterate a dictionary, we get the keys back. So this means we can actually sort it. And if we call sorted on D, what do we get back? Well, we get a list. Remember, we always get a list back of what? Of the keys that have been sorted, right? So here when we iterated through the dictionary, we got DEF first, then ABC, then GHI, but we got it sorted, right? And again, lexicographical ordering. Okay, well that's great. But what happens if we want to sort this dictionary not by the key, but by the value? We still want to return the keys, but we want to return the keys in order of ascending associated value, right? Well, we can do that again pretty easily using key equals. And here we're going to say lambda. Now we're going to take an element, let's say E, right? Let's call it E. That's what we're iterating in the dictionary. But what do we want to use? Well, we're going to want to use the value, right? So how are we going to get the value for this key? Remember, this is the key that's being iterated. So we're going to take the dictionary. We're going to look at the value that's at that key, right? So instead of sorting by the key itself, we're now going to sort by the key's value. And by default, it's an ascending sort. And yeah, I'm going to write my lambda expression correctly, right? So we're going to take an element, which is going to be a key, because we're iterating through a dictionary, and we're going to look at the value associated with that key in that dictionary D. So when we run that, we now get GHI, ABC, DEF. And as you can see, GHI had a value of 100, ABC had a value of 200, and DEF had a value of 300. Hence why it came back in that order. Next, we can look at something else. Maybe we want to sort a list of complex numbers, and we want to sort these complex numbers based on their distance from the origin, right? It's just going to be the Euclidean distance, so it's going to be the square root of the real part squared plus the imaginary part squared. So let's try that. Let's see how we might do this. So first, I might actually define a function. I just want to show you that you don't have to use a lambda, by the way, in the sorted method. So let's do that. Let's create something that's the distance. Now, I'm not actually going to use distance. I'm going to use distance squared. I don't need, in order to do the ordering, I don't need to actually take the square root, right? Because square root retains ordering of numbers. So if a is greater than b, then square root of a is greater than square root of b. Of course, I'm assuming positive numbers since we don't have, well, I know we do have square root of negative numbers, the complex numbers, but in this case, we're looking at distances, so they're always going to be positive numbers. So in order to do the ordering, I don't really need to go to the extra step of calculating the square root. So I'm just going to omit that. And so here what we are going to return, we're going to return x real, right? The real part of x squared plus the imaginary part of x squared, right? That's our distance. So if we look at the distance squared of, let's say, 1 plus 1i, right? Or 1j we have to use, right? 1 plus 1j is a distance of 1 and 1 in the real and imaginary axes. So its distance is square root of 2. So the distance squared would be 2. and that's indeed what we get, 2.0. Anyways, so that's how we can find the distance of a imaginary number from the origin. So now let's go ahead and create a list that's got some numbers in it. So let's say we're going to take 3 plus 3j, 1 minus 1j. We'll take 0, which is just at the origin itself, and maybe we'll just take a pure real number as well, which is just 3. So we have that. Now if we try and do sorted on L, that's not going to work. Complex numbers do not have a built-in ordering in Python. So if we do that, it's going to tell us, hey, the less than is not supported between instances of complex and complex. Well, yeah, right? There's no ordering defined for complex numbers. So here we are going to use, again, the key. We have to use a key in this case, and the key is just going to be distance sq, right? That's all we're going to do. We're going to apply that distance function to each element of that list L and sort based on that. And so when we get that, we see obviously the one that's closest to the origin is 0, right? Then we had 1 minus 1j, that's a distance of square root of 2. 3 plus 0j, well, that's going to be a distance of 3. And then 3 plus 3j is going to be a distance of the square root of 3 squared plus 3 squared. So 9 plus 9 is 18, square root of 18, right? So it seems like the ordering is working correctly. So here's how we would do the sorted. Now, we don't have to define this function first, right? I had to think about this, define the function first, and then do my sort. Instead, we can do this all in one shot using a lambda. We can just say key equals lambda. Lambda is going to take some element x, right? That's going to be in that list, so a complex number. And we're just going to use that. Whatever we had right here is what we're going to use. So I'm going to copy paste that right into here. And if we run that, we get the same result because the lambda was used. So that's another way of using lambdas in the sort. You can now actually sort elements that don't have an ordering as long as you associate a function that will give you an ordering for each element. Let's look at one last example of how we might use sorted. Let's say I've got a list which contains some strings. So let's say I've got Cleese, and then idle, then Palin, or Palin, I guess, Chapman, Gilliam, and Jones, the Monty Python crew. Okay, so now of course we can sort this list, right, just in the normal lexicographical ordering, so Chapman, Cleese, Gilliam, Idle, Jones, and Palin. But what if we want to sort based on the last element, right, of each name? So I don't want to sort by the first character, I want to sort by the last character. Well, that's pretty straightforward. We can do, again, sorted L, key. Now, key is going to be something. We're going to define a function that's going to take each string and just return the last character. So we're going to take a string s and we're going to return the last character. So if we sort this way, you'll notice that now we have Cleese, idle, so E, E, M, N, N, and S. So that's definitely sorted in ascending order based on the last element, the last character of each string. Now what about the ties? Basically here we had E and E. Why does Cleese come before idle? Well, it kind of makes sense. C comes before I, so maybe that's what's going on. But look here, we have N and N. We have Palin and we have Chapman. And N are both the same, but P comes before C if we look at the first character, right? And I certainly doesn't come before A, so it's not using the second last character either. What's going on? Well, sorting in Python, the way they've implemented the sort, it's called a stable sort, which means that if you have kind of an equal, right, two things are actually equal, not one is not greater than the other, like for example Palin and Chapman, it will retain the order in which they were specified originally in the list that you're trying to sort. So this is why Cleese came before idle, because we had actually defined Cleese before idle in this list over here. On the other hand, Palin and Chapman, well, they're again equal, and again, Palin was defined before Chapman. Hence, it comes before Chapman. So just to show you, I'm going to take the same list again, paste it down here, but instead of putting please before idle, I'm going to put idle and then please. Okay, so this is our list now, and I'm just going to rerun the sort, and now you'll see that idle now comes before please. And that's because in terms of the sort ordering, because we're only using the last character, they're equal. And because it's a stable sort, it retains that order. So just an interesting side note on the sorted method in Python. So this is a typical example of how you might use Lambda expressions, right? They're very handy. You don't have to go out and define a separate function using def. You can just inline it essentially. And these are short, very simple to understand functions that make sense to use in this kind of context. All right, thanks for watching, and I'll see you in the next video.